Here's a template class. This is a very naive accumulator. It keeps a running total. It's not necessarily a paradigm of exactly how to write accumulators that keep running totals. There are things that will do this for you in the standard library, but I wanted to choose a class that you could easily see how it worked. This is in a header file, and there is no accum.cpp. That's pretty normal that everything is in the header file so that it can easily be brought in by the compiler everywhere that it's used. As with the functions, you notice we start template class T, and then we are defining a class, and this is the end of it as usual. And inside we use T for the type placeholder, just as in the function. So accum here, if you're making an accum of ints, it'll have an integer total. If you're making an accum of floats, it'll have a float total. It has a constructor that takes a starting value. It's probably going to be 0, but we're going to have a constructor that lets you pass in what your starting value will be. And all it will do is, using C++ initialization syntax, initialize total to that starting value. Then we have an operator plus equals. It returns a type and takes a type reference. I'll explain the const later in the material on pointers. We'll get into const. For now, when you take certain things by reference, you have to say const, otherwise you can't pass in a literal like 3, which is a constant. Treat that as a little bit of a magic word for now. We'll come back to it. Operator plus equals, this is just ordinary common or garden operator overloading. When you add t onto the total, we should increment total, so total is equal to total plus t, and we'll return that value. That may be of some value if people are chaining them or using them to pass down to other functions and that kind of thing. And then I have a member function called getTotal that provides access to the total, and it is returning type t again. So if total's an int, this returns an int. If total's a float, this returns a float, and so on. And I have some code here that uses it. Now, when you instantiate a template class, you do explicitly specify the type. So here I'm saying I have an accum of int, and I've happened to give it a name, integers, but you could, of course, call it hello or Tuesday or whatever works for you. And I'm passing in a starting value, which makes sense that we start at 0. And then I just use plus equal a couple times and add more integers onto my accumulator. And then I ask for the total and print that out. Do the same thing with strings. I call it strings, and this time I initialize it to quote quote rather than 0. That obviously makes more sense for strings. And I'm going to put in hello and world. And the rest of the code in this main is commented out. So let's just run this and show what you get. So when we put 3 and then 7 into the accumulation of integers, we ended up with 10. And we put hello and space world into the accumulation of strings, we ended up with hello world. So this works as advertised. That's nice. Good, simple, easy to use. And apart from the angle bracket syntax when you declared them, after that it's just perfectly ordinary class, and you just use these intuitive operators and member functions. Now what do I have commented out down here? I have attempt to break the rules. I've mentioned a couple times that templates give you type safety. Integers is an accumulation of integers, and its plus equals operator takes an integer reference. When I try to use a string, you can see I'm going to get red wigglies. It says no operator plus equal matches these operands. And similarly, strings is an accumulation of strings, and when I try to add in an integer, it says no operator plus equals matches these operands. I will build it to show you the compiler errors that you get in the output window. There's a lot more of them, and they can be a little more intimidating. They do contain the same fundamental complaint that you saw in the tip. No operator found, which takes a right-hand operator of type const char at 8, and then showing you that this is int accum of t's operator plus equal. And just that, seeing t here and here, is your biggest clue that If it's an accumulation of integers, you should add integers into it. And if it's accumulation of strings, you should add strings into it. This kind of type safety is a feature. This is what we want our templates to do for us, to let us write the code once and use it with a variety of types without forgetting what the types are, keeping all their true nature as an integer or a string or a person or a bank account, and getting the compiler, our friend, the compiler, to tell us when we mess up. So these lines don't compile because our accumulator is type safe, and that's what we want. Here's the code you just saw in the demo. You start by writing the class out, just using a placeholder instead of the type. We accumulate T, whatever T is. I have an ordinary class definition with a private and a public section, member variables, operators, constructor, member functions, really nothing unusual. And when you use it, you tell the compiler what type you'd like the template instantiated for. So I'd like to accumulate ints, or I'd like to accumulate strings. The compiler will not check on this line and say, is it okay that you're using this type? Is int appropriate for the accum class? It will check as you use or exercise members of accum. So here you're going to exercise the constructor, and if there wasn't a constructor that was happy with having the number 0 passed to it for an accum of ints, if there wasn't a constructor that's happy with having an empty string passed to it for an accum of strings, you'd get a compiler error. If the appropriate constructor was there but something else wasn't, that's when you'd find out that there were issues. So just as with the template functions, it can be a little challenging to understand your compiler errors. But in many cases, the compiler errors are actually a feature. Once you've made an accumulation of ints, you can't add strings to it, and vice versa. And this type safety is a big part of what's good about templates. There's another thing that sets C++ templates apart from the way just about every other language does generics, and that's specialization. The compiler will generate the code using the template for any type you pass it, but you can say, here's the code I want you to generate for this particular type. In other words, write the template once generically. Here's how to find the max of any two things. And then again, specifically, here's how to find the max of 2 employees or 2 bank accounts. Why would you need to do that? Well, the thing is that sometimes templates don't work for certain classes. You saw that max relied on operator less than, and accum relies on operator plus. If you haven't overloaded the operator for those classes, how can you use the template with those classes? Or if someone has overloaded the operator, but it doesn't do what you want the template to have that operator mean. When we're working with the simple classes that you see here, it's really simple to decide what plus means. You want to add 2 people? I guess the only thing that makes sense would be to add their arbitrary numbers. But what does it mean to add 2 bank accounts or to compare 2 employees? The best thing to do is to add the missing operator. As you know, you can write any operator overload as a free function. So even if you're not the developer of bank account or employee or person, you could add the missing operator as a free function. That's an excellent choice. It may have other benefits in other parts of the application as well. It doesn't work if someone's already written it. And there are other times when it's not an option either. So you do have a second choice, which is to specialize the template. This means you write a version of the template that doesn't have the placeholder in it, and that says, here's how to specifically do the work I want to do for this incompatible class, for this employee or bank account or person object. Once upon a time, the #1 motivation for template specialization was C-style strings. a good reason for template specialization when our sample templates are so simple, but I want you to see the technique, so I'm going to show you how to do it. You will need to do it at some point because templates are just such a huge time saver and productivity boost for developers that when you find one that isn't quite right, you need to know how to make it fit your situation.